With our variable length subnet masking, we haven't really talked much about the class environment, Class A, Class B, Class C. We still use those references, although the infrastructure that we use today isn't really a classful network. We use classless interdomain routing, or CIDR, 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 slash notation, whatever you want to call it. But we still do get references back to our Class A, Class B, Class C structure. So we should take a look at those values so that you understand how that classful addressing actually works. In classful addressing, the unique group of addresses that we have, Class A, Class B, and Class C, are generally what's considered the global internet address space. So my Class A addressing space, numerically in the very first octet, is 1 to 126. What does that mean, the first octet? X.Y.Z.T. It's the X octet here that determines the class of the address. So the X value, the leftmost, the most significant octet, if it's 1 to 126, it's a Class A. If it's 128 to 191, it's a Class B. And if it's 192 to 223, it's a Class C. Now, you look at those numbers, they don't look like they have much of a pattern, do they? It's like, where did this come from? What were they doing, rolling dice on a table someplace to come up with these values? And it turns out they actually did have a specific meaning for it. So when we convert this first octet, let's say whatever the decimal value is, when we convert it to binary, if the very first bit is a 0, that's actually what defines that Class A. I don't care about the rest of the bits. So I have 8 bits in that octet. If the first bit is a 0, that's the definition of a Class A. So all the way from 0, 0, 0, 0, 0, 0, 0, 0 through 0, 1, 1, 1, 1, 1, 1, 1 is the Class A address space. The Class B address space, well, if the first bit isn't a 0, it's what's binary. So if it's not a 0, it's got to be a 1. So the definition of a Class B is if the first bit is a 1 and the second bit is a 0. Again, without regard to the rest of the bits. So if the first bit is a 1, the second bit is a 0, and the rest are zeros, that's the first address in the Class B space. And then it's got to be 1, 0, 1, 1, 1, 1, 1, 1. That would be the last address in the Class B address space. And the pattern's going to follow. If the first bit is a 1 and now the second bit was a 0, but now it's a 1 and the third bit is a 0, that is the definition of a Class C address. So again, 1, 1, 0, 0, 0, 0, 0, 0 through 1, 1, 0, 1, 1, 1, 1, 1 is my Class C space. Now there actually is a Class D address space as well. This is not globally unique. This is the multicast space. So multicast is the Class D space. And the Class D space is from 224 through 239. Any guesses on the binary pattern? Sure, 1, 1, 1, 0 without regard. So 1, 1, 1, 0, 0, 0, 0, 0 through 1, 1, 1, 0, 1, 1, 1, 1 is the Class D space. And there is in fact a Class E, which is the rest, which is 240 through 255. This is experimental or reserved for future use. And by definition, 1, 1, 1, 1 without regard is the Class C space. So 1, 1, 1, 1, 0, 0, 0, 0 through 1, 1, 1, 1, 1, 1, 1, 1. Numerically, what are these values? Well, this would be 0 and this would be 127. This will be 128 and 128 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. Yeah, 191. This is 192. This is 223. This value will be 240. This will be 239. Did that wrong. It's 224. Something happened with my pen. Sorry about that. We can just put back. We're good now. So this was 224. Note the change because it's 128 plus 64 plus 32, which is 224. and that would be 239, and this one is 240 through 255. Now, here's the range that I specified for A, 1 to 126, but it looks like it's 0 to 127. That's because we reserved 0. The inventors, the people who put this together, said we can't use 0 here, so it actually starts at 1. And then they reserved 127 for loopback. So 127 dot whatever, x dot y dot z is reserved. Wow, I wrote 120, it's 127. It's gonna be one of those mornings, isn't it? 127 dot whatever, this is the loopback address. And that entire space has been reserved for testing, just testing the software stack, testing your network, testing the local network stack that's on the local machine. So you can't use 127, so the actual range is 1 through 126. That's the classful addressing range, the definition of why the numbers are what they are, and what that binary value actually looks like.